All right, everyone. I think we can start again soon. Very well. Welcome all to this last session of the day. I am Timothée Peruchou. You can call me Tim. I'm from BEPA, the Batteries European Partnership Association, which I guess most of you may know about. Very happy to be here. Thanks for the invitation. It's a great honor, and we're always happy at BEPA to be here with ongoing projects and keep on following what's going on. So, without further ado, we're going to go with COLLABAT cluster introduction session now, with our next generation battery packs for the automotive industry, and I will introduce now the very first speaker, who will be Tomasz Jasinski. From the Helios project. He is a market research expert working as freelance consultant for International Copper Association in the European branch. And he has more than 25 years of experience as technical market research professional and focusing on various areas of energy, including e-mobility. And he will talk to us about the hybrid modular EV battery pack solution from the Helios project. So Thomas, the floor is yours.
Okay, great. So good afternoon, buongiorno. Yes, thank you, Timothy, for the nice introduction. Thank you, Marina and Eduard, for the kind invitation here. And you have to bear with me twice, so I will have two short presentations. First of all, I will have the pleasure to tell you what is COLLABAT. So COLLABAT is a cluster started from an LC-BAT 10 call. 4 projects have been awarded by the Commission, starting with more or less the same objectives. And we formed a cluster. And where are we? So we are in the here in the middle. So we're not into materials, anodes, cathodes, etc. We're not into the cells themselves. So we buy cells from the shelf, if possible. And we do each and everything. We do the pack integration, module pack integration, we do the vehicle integration, we do the tests in use phase, and of course we are into recycling, second life, etc. So that's where we are in the value chain. This call has been put from the Commission on the table because we need to push the market uptake of battery electric vehicles and also plug-in hybrids. So there's still a lot of customer reluctance, and we don't see this uptake really happen for several reasons. One is we need more compact, lighter batteries, meaning we need more power and more energy density into the pack to give them more performance and range. And we also need shorter charging times. Customers are not willing really to wait 1 hour or 2 hours on the motorway if they want to drive. So some of the objectives, these were common for all the 4 projects, were reduce the weight by 20%, extend the lifetime of the battery, so safe and reliability during operation 300,000 kilometers, which is quite a lot, because normally the OEMs give you 160,000 or 8 years. So we are almost double. Of course, we want to also improve the environmental impact. So 20% life cycle assessment improvement has to be achieved. And we want to get more knowledge on sensors and thermal management. I will not go into the details of each of the projects because I will present Helios in 2 minutes. MARBEL has been a topic all the day here, so I have a lot of information already digested. Albatros will be presented by the coordinator Eichel also in a while, and Liberty by the colleague from Ikalan, Maida. What I'm very proud is because, of course, what you see on the bottom here is a typical dissemination activity. So we organized webinars, joint events. We had a very nice COLLABAT workshop, half a day in Barcelona, side by side to the Battery Innovation Days. where we engage with stakeholders, we present results. But what was really, really new for me, at least, was that we worked in closed doors expert groups. We called them subclusters. So meaning people from the 4 projects were sitting together and working on different topics and seeing, are there synergies, are there complementary effects, what are my challenges, what are your challenges, not going into intellectual property or confidentiality, but just discussing. And then when you discuss already, what is my challenge? Then you're starting thinking, and what is my approach? What is your approach? So we defined 3 of them. One was on LCA sustainability. The second one was on testing methods and validation. And the third one was on BMS. We're looking into a 4th one, modeling, which did not fly off. But these guys really then discussed more or less on a monthly, bi-monthly basis, and there were really fruitful results bilaterally and among all the projects. And we hope that we provided some inputs for new projects as well. Of course, for academia, there are papers issued, and we had a series of webinars. And yeah, these 4 funder projects, Liberty finalized officially in December, MARBEL is about, Albatros in June, and Helios finally in August, will end. But we are lucky, we have 2 new project members, which will continue, which will keep the flame alive, which is InnoBMS and iBatman. These are basically related to BMS topics. So a little bit narrower than what we have, but it's a good extension. And we have both here as well, Cornelio from iBatman and the colleague from InnoBMS will connect remotely, so I don't need to explain. So then here, for your information, you will get all the project websites and the contact information. Okay, so now it's my more personal turn. I'll try to explain you the Helios project, Hybrid Modular EV Battery Pack Solutions. So Helios stands for High Performance Modular Battery Packs for Sustainable Urban Electromobility Services. Oof, huge. Important here is modular. So we were funded under the same call as the other 3 as well, roughly 10 million euros co-funding from the Commission plus internal funding as well. We officially would have ended in December. We got an extension because of several reasons. Mainly the cell selection took more than 1 year longer than expected. As I said at the beginning, we do each and everything, but not the cells. So we buy the cells. And before you can buy the cells, you need to find suppliers who are willing to sell the cells. And you need to find the right cells. And we had the issue here in MARBEL that they had to change cell suppliers in the middle of the project. So it's quite complicated. We are 18 partners in Helios, so a good mix here of academia, research institutes, industry, which with Tesco, which is now Schaeffler. And we have one bus manufacturer, OEM, Bozankaya from Turkey, which will integrate the battery pack, one of the demonstrators in a 12-meter e-bus. So, as I said, we do each and everything except the cells, meaning it's a quite complex story and a quite complex project with all the different elements connected to each other. Today, I will only talk about very few topics, but of course, we had to select the cells, test the cells, do the mechanical, electrical design, thermal management, BMS and sensors. We have digital twins and IoT platform, which can be used then later by fleet managers. We consider a second life application, and of course the LCA and LCC analysis is also an important part of the project with all the different partners here involved. We set clear objectives. We want to reduce 30% of the weight and 20% of the volume compared to a Tesla Model 3. This is the benchmark. We want to charge a small EV passenger car in about 6 minutes at super fast charging, 360 kV, which Vestel, the partner in our project, will provide the hardware, the charging stations and the connections. We want to prove the lifetime and the improvement in life cycling. And the scalability of our solution should be shown in two demonstrators, one in a small Mitsubishi car, which is available at the University Aarhus, a partner and coordinator of the project. But here we will only do hardware in the loop because we cannot communicate with the CAN metric of the bus. Mitsubishi is not part of the project, and they're not willing to give us the full access, of course, but we are lucky that with Bosankai as a bus manufacturer, a partner in the project, so we can really communicate and bring a full, real, live demonstrator with the Bosankai bus on the road, or at least on a track. So what means hybrid? We started with the vision that for the same model, for the same car platform, there are different customer types. Are you more sporty drivers or no long distances, but you want to recharge in definitely less than 10 minutes when you are on your track on your way home? Or are you more the sales rep, the long distance traveler? You go from A to B and then you make an overnight, or you are at the office all day. So you don't need super fast charging. You can charge overnight, but you won't really have the right range. I want to know that I can go from Hamburg to Munich, and that's challenging, of course. So customizing the battery pack to the end use, but using the same boxes, the same toolbox, that was the idea of the hybridization concept. And how we do this, so we have high power modules using LTO cells, and this in our case is Toshiba, and we have high energy modules on the other sides, NMC pouch cells from Ferasis on the other side. So you see, we're not only mixing two different chemistries, LTO and NMC. We're not mixing them in the same module, in the same box. So we have separated modules, but in a pack, we are a combination of both modules. Different chemistries and also different cell types. Prismatic Toshiba on one side and pouch cell Ferasis on the other side. In between, of course, we add a little bit more complexity on the converter side. So the DC, multi-level DC-DC, of course, means costs and complexity, but we need this to guarantee the balancing and the exchange of power and energy to guarantee both. So you have more range if you need it, and you have super fast charging, and you have peak power if you need it. And so modular in our concept means that the boxes are looking the same. The size and the shape of the boxes, high power here and high energy, has exactly the same size. Of course, the weight is different because the prismatic cells are heavier than the pouch cells. But this means that you can configure for the same car model whatever you want. 6 plus 3, like in this case, 6 plus 6, 6 plus 12, 3 plus 12, whatever you need in the combination between more high power or more high energy. And the boxes in the same way, and they're connected the same way. So this means modular, and this means absolutely scalable. Of course, the power electronics are important to shift the load between. We need a complex power electronics architecture, and also to avoid cell degradation and extend this 300,000 kilometers in first use. And also this power converters to enable the super fast charging. In our case, coming now to how we build them from the modules in a modular way, a scalable way, to the pack. We integrate them in a so-called sub-packs. Sub-packs is an aluminum frame. It contains 4 modules from the same type. So either 4 high energy modules or 4 high power modules. So also the sub-packs have the same size and shape. And they have an integrated and complete thermal circuit, which is forced air cooling, closed loop, and a bottom cold plate with a serpentine, which you can connect to a cooling fluid in addition if you want. So every sub-pack basically has its own thermal circuit. And then we, for example, for the small Mitsubishi, we put 3 sub-packs into the battery pack with 1 DC-DC and wireless BMS system. And of course, finally, we are now in the phase of analyzing also the environmental impact. So the first results have been published in a paper, and it shows good results that we are on track, so that our approach definitely has a lower LCA impact compared to the benchmark. And we have a contribution to circular economy, to environmental footprint, and to a better recovery and reuse of the battery, which is a very important issue today. We are not into battery, if the question will come maybe later, we are not into the battery passport. So once we started a proposal, which was years before we got awarded, the battery passport was not an issue, and we did not include this actively in our project. Now, of course, we had some discussions in the cluster as well, but this is not part of Helios. I'm not going into all the details, but you see there's a lot of technologies on power electronics, on sensors, on algorithms, on digital twins. And all these have started at relatively low or mid, I would say that at mid TRR level 4, and we are jumping to the next stage. So we want to achieve at least TRR level 7 at the end. So a good proof of concept that these strategies work. And now we're still in the phase of integrating everything into the packs, testing, and then putting the 2 demonstrators. As I said, the Mitsubishi will not be on the road. It will be just the hardware and the loop situation where we'll test, simulate everything on a test bench. But the plan is to have the Bosankaya bus running by summer. And any questions, the coordinator Cornelio is as well the coordinator of IBATMAN, so is here today, and I'm here today. Thank you.
Thank you so much, Thomas. I'll go straight to the next speaker, Maider Uzabiaga Carrera. Please pardon me if I don't pronounce your name right. I am French after all. So Maider is a researcher and project manager at Ikelan in industrial engineering, and she has been involved for more than 20 years in researching and managing energy projects in Ikelan, and is now more specialized in energy storage as well. Thank you. Your floor is yours.
Hey, so good afternoon, everyone. So Liberty is the result of a successful collaboration of 16 partners from 7 European countries along 4-year project work together. The coordination was in hands of Ikelan. My colleague Eduardo Miguel was in charge of that. He couldn't make it to be here today, so I will do my best communicating the project to you. So on the right part, you can see a picture of the final event we had in December, 3 months ago, when we finished the project in Stuttgart, in Mercedes headquarters, in a very similar event as the one we are having today, also with other COLLABAT projects being presented there. So today is a bit the other way around. So thank you very much for the invitation, and we definitely congratulate for being part of COLLABAT. So in my presentation, I would like first to tell you a bit about what were the challenges, the objectives we had at the beginning of the project. Then I'm going to tell you about the strategies and the innovations we put on it to be able to achieve those objectives. And finally, I would like to show you some nice results we got at the end of the project. So that was, so first of all, let's start with the objectives then. Those are quite common to all the projects that are going to be presented. now in this pack. So that was year 2020 when we were thinking about and giving shape to the project. And at that time, we were envisioning a battery system that would provide 500 kilometers range. That would provide also fast charge at high power, 350 kilowatts, and thus halving the charging time. Halving it. We definitely wanted it to provide 300,000 kilometers lifespan. Also having additional safety standards on it, and all that wrapped in a methodology that would very much take care of the sustainability of the whole concept. So that was the challenge we had. And how did we make it real? Well, in the following, I'm going to tell you about which were our decisions and our developments and achievements. I'm going to tell you about the cell-to-pack design, the immersion cooling system, a very interesting one we developed in the project. Also about the innovative safety and thermal runaway protection, the integrated BMS and haste algorithms. And I'm going to finish with the LCA integrated in the design and the verified performance testing, some KPIs, and the expected impact. So the first question, big question we had was, what is the maximum energy we can fit inside an existing EQC frame? And the answer went very much in the direction of trying to get the most dense NMC cells we could have available at that moment and put in as much of them in the free space so that we were assuring of a very efficient space utilization. We also developed quite a lightweight housing where we replaced part of the aluminum parts for composite parts that were also recyclable, and they allow us to spare some weight, 20% of it at this point. Then to connect all that cells and make it work efficiently, we defined a high voltage electrical subsystem that would work at 800 volt. And we also designed a semiconductor-based main switch, a highly integrated cell contacting system with an advanced BMS on it. And we also integrated a low power pressure sensor in our pack. And very connected to this cell, very integrated to it, we designed an effective and efficient cooling system too. So let's have a look a bit more in depth on that. So we knew that the cooling system was going to be one of the big keys of our whole concept. We know that whenever we are talking about battery thermal management, we always have to find a trade-off between affordability, safety, performance, and durability. So our colleagues from Valeo decided to go for a very innovative partial immersion cooling. So the concept is a bit like this. So we had approximately 1/3 of the height of the cells submerged in a liquid, in a I lost the word, in a dielectric fluid, and this fluid was then pumped through a chiller where it was cooled and then directed to some nozzles so that the liquid was then sprayed over the busbars on the top of the cells so that they were cooled, and the liquid was coming down again to the bottom so that a new cycle could begin again. So to make this concept be implemented in our battery pack, so there was a lot of engineering behind, and they had to select all the pumps and all the ducts to conduct all this dielectric fluid and direct it to the nozzles to spray it over the cells. And it may look quite a fancy system, but in fact, it worked very, very well. And as we saw in the testing, we end up having a very homogeneous and haste cooling of the cells and the bus bars. And that was very important for us for allowing fast charging. And it also improved the lifetime of the cells due to the improved cooling. And even in a dedicated test, we saw that it could aid for thermal runaway propagation containment. So we still added more safety to our concept with some active safety system and passive safety system that worked out by Hutchinson. Some of them are patented. So both went in the direction of stopping and blocking any thermal runaway event we may have inside our battery pack, so that there was an affected area, but then we were able to block the damage and leave undamage the rest of the cells. So safety is something that has to be seen from different perspectives. Crash safety is also very important. And here we made a lot of mechanical testings and simulations at cell level to gain knowledge on the mechanical behavior and the deformation behavior of the cells. And we even developed a cell level shortcut detection tool. We, of course, work also with vehicle representative pack loadings, so that we were also able to prove that our concept was totally safe also from this perspective. And what else? Well, we worked also in advanced BMS. Fraunhofer, which was part of the consortium to work for a specific adaptation of their FOX BMS. We also developed some very nice cell contacting system in which we integrated NXP slaves. And yeah, remember that all that were in the wet area of our cooling system, so they have to be prepared for that. We work also in the BMS to cloud connectivity in advanced algorithms based on transfer learning, so many things, but I've got very little time. But I would definitely would like to mention, for example, that during all the process of designing all this, there were some colleagues taking care of the sustainability of everything we were doing. And at the end, they could account for 70% safety savings in resource and 21% savings in greenhouse gas emission, which is not bad at all. We know that the main environmental impact of our pack is coming from the cell production process itself, which is something that is out of the scope of the project. But we also learned that the major improvement in this positive impact we were having was coming from the increased longevity we achieved with our concept in the pack, and also from the recycling efficiency due to a specific procedure that was developed in the project for recycling the pack. So I would also like to tell you something about the different testing levels we made. We made quite an extensive testing along the whole project. We made load cell performance lifetime and safety tests. For example, in here, you can see some tests, cell tests, in which we are studying the effect of the pressure in the lifetime of the cells while we are charging at high rates. We also made some cell stack level testing that was especially useful for tuning some performance details and issues like, for example, the nozzle design. and also was useful to prove some safety concepts that we were using in our pack. And finally, one of our big achievements was also to build a completely operative battery pack with including all the innovation I have just mentioned before. We were able to test it and measure its capacity and its fast charge capability, for example. Yeah, in this video, it's working. It's not working. Yeah. So here you can see an animation of how the temperatures of each cell in the pack change along a fast charge. We are doing at 350 kilowatts, and you can see how homogeneous the temperatures are, how well the cooling is working. We also calculated the range in real near real road conditions. That helped a lot quantifying our KPIs. We also made some safety and abuse estimation of the whole pack via simulation, and we were also able to successfully prove the vehicle integration of the pack. So this is my last slide. I would like to finish showing some KPIs we obtained in the project. As you know, the European environmental policy for climate neutrality by 2050 is pushing very much for the rapid implementation of electrification of transport. So how do we think that Liberty has contributed to that? So looking at the figures, we can see that with the technologies and the processes we implemented, we were able to increase considerably the capacity, the range, and especially the mileage of our pack and reducing the weight of it. So we think that we are in the direction of impacting in the decrease of the range anxiety and promoting EV penetration. We also proved that it's possible to enhance the fast charging capabilities of our packs, so we can also boost again the increased range and minimize the range anxiety. We have also demonstrated that with the active and passive safety measures, we can make a difference in the thermal runaway propagation in the pack, and therefore make batteries safer, more reliable, and mitigate the negative impact of safety events. And finally, looking at our nice figures on the LCA analysis and the improved battery lifetime we obtained, we really think that we are also in the direction of enhancing the sustainability of EVs and fostering an environmental friendly transport ecosystem. So that was all from my side. Thank you very much for your attention.
Thank you, Maider. And I forgot to mention earlier, but similar to the previous, that happens. Similar to the previous sessions, we will have a Q&A after all the presentations. So please remember or note down the questions you have for all the projects coming first. Next up is the Albatross project, represented today by Aysel Pilav. Aysel has been working as R&D project expert at Yeşilova Group, which is based in Bursa, Turkey, now for over 3 years. And she's a leading manufacturer, of industrial aluminum products, primarily for the automotive sector. And Aysel, whenever you're ready.
Good afternoon, everyone. Thank you for this opportunity. I am here on behalf of Yeşilova Holding. My name is Aysel, and I will introduce to you the Albatross project. So our project started in 2021, and it will end in this June with 6-month extension. The total budget is almost around 10 million euro, and we have 21 partners from 10 countries. Let's jump to our partners and technologies they brought into this project. I am not planning to go through them one by one. However, to sum up, our partners have come together to develop an advanced battery system which is scalable and can be adaptable to not only the old passenger car applications, but also different size of vehicles, such as heavy and light duty vehicles. To do this, a BMW i3 was chosen as a platform to demonstrate the further developments. The developments focus on BMS, TMS, and sensing, battery modules, battery trays by considering the welding and joining technologies, eco-design principles, dismantling, battery secondary life applications, and recycling. What we aim to do with this advanced battery pack, as all of the sister projects, our goal is to create a battery pack system which can makes EVs much more lighter, faster charger, longer laster, and more environment friendly. If we need to talk about some specific numbers, at the end of the project, it is expected from us to increase the energy density, cell energy density, around 40%, while decreasing the battery weight around 20%. And it is also expected from us to increase the battery capacity up to 55 kWh, while reducing the charging time down to 30 minutes. And it is also expected from us to extend the driving range up to 480 kilometers, and the lifespan up to 200,000 kilometers. And also it is expected from us to integrate smart sensors and AI-driven BMS system while integrating the very fast safety detection and prevention technologies. And lastly, sustainability is also something we focus on, and it is expected from us to improve the full life cycle of the system between 15 to 20%. So if you ask me which of these objectives have been achieved so far, I can tell you that we failed in weight reduction. The driving range and the lifespan will be clear at the end of the project. However, I can tell you that the rest of them has been achieved. So I would like to give you some details of the studies, the results of the studies we have performed. But before going through them, I want to state that we are in the validation phase of the system. We will integrate the system into the vehicle and start the validation. For this reason, the results I will share are mostly component level results. Let's start with battery modules and packaging. Albatros system consists of 16 scalable lightweight modules with embedded cooling channels for partial immersion cooling. We achieved 259 watt-hour per kilogram energy density on cell level, and also 217 watt-hour per kilogram module level energy density, which is an improvement over i3 as well. And the total battery capacity is 55 kilowatt-hour, which is another improvement with 31%. The modules are fully laser welded on laser cut bus bars, and as a result of these studies, partial immersion cooling has been evaluated for patent application. Regarding the battery management system and thermal management sensing system, Albatros has master and slave architecture. This architecture has been designed to give the system flexibility, and it can be easily adapted to different pack configurations. We have some advanced functionalities like electrochemical impedance spectroscopy for cell analysis, AI-based SOX algorithms, and end-of-life determination. Our system is also compatible with ultra-fast charging. It uses partial immersion cooling, printed temperature sensors, and anode-controlled charging. The system can provide thermal measurements from 770 different points, which is a wider and sensitive measurement compared to the existing system. And Algolion software has been implemented into this system to avoid thermal runaway. It helps to detect early thermal runaway detection. As a result of all of these studies, 4 different patent applications has been done by FEV Turkey. Regarding the battery trays, Albatros battery tray has a structural role in this project in order to reduce the weight of modules. And while to do this, it has a hybrid approach, both on manufacturing and material side. The base material is aluminium, and the top cover is made of composite. The aluminium parts are produced by high pressure die casting and extrusion. The bottom plate of the structure welded by friction steel welding. The frames are welded by laser welding, and the whole structure welded by CMT. And the side walls has some composite patches in order to reinforce the structure. But despite the weight reduction in BMS, TMS, due to the cell selection and the structural role of the tray, as I mentioned before, we failed in weight reduction. And we noticed this in the early stage of the project. And we wanted to also explore the effect of the weight increase on range. In order to do this, we conducted some simulations by using GT Drive to understand the impact of the weight increase on range. And according to the studies, the result says that the higher battery capacity, such as 72 kilowatt hour, the vehicle range increases, which is expected. However, the weight increase of almost around 2 kilogram, the 200 kilogram, does not impact the overall vehicle range. And the third one, dismantling, second life, reuse, and recycling. Albatros system also, Albatros has developed a system, semi-automated dismantling system for the battery dismantling. And we are able to determine the state of repair of the individual cells with the real-time algorithm. And at the same time, we are able to detect the faulty cells successfully with this algorithm. We are able to assess the suitability of the cells for second life applications as well. And we develop an algorithm for end-of-life and state of function estimation. And lastly, we develop a compact process to recycle the battery coated active material. The recycling, we achieve a recycling rate around 80% recycling for lithium. And the last part I want to mention is life cycle analysis and sustainability. Under this work package, we develop a knowledge-based engineering system which automates eco-friendly and optimized design for battery cells and packs. It helps to give you thermal management, thermal simulations, and it helps the users to create some customized battery configurations. In parallel, we conducted life cycle analysis. This life cycle analysis started with the comparison of existing one and the new development one. In the first one, we didn't include the second life applications. We just wanted to see the effect of the capacity increase, and it shows that it is also which is expected. When the capacity increases, the carbon footprint increases as well. But when we run the second analysis with including the second life application, it showed that regardless of the electricity grid, our developed system will have less carbon footprint than the existing system, around 30%. So these are the results that I want to share with you. So far we have achieved for Albatros. Thank you for your attention.
Thank you, Aysel. Okay, I'll present the next speaker while they are revamping the mic. So next, we have a presentation of the two new cluster projects, cluster members. As Thomas indicated earlier, it will be iBatman and InnoBMS. And the first project, the first person we'll have today is Cornelio Barbo, who's associate professor in the Department of Electrical and Computer Engineering at the Aarhus University, and specializes in electrical energy technology. Please, you have it for Mr. Barbo.
All right, quick overview of iBatman. So we started beginning of last year. It's essentially a BMS-based project, 5 million euros. It's a 3.5 years project, basically looking into what's called next generation BMS, combining various features, edge, cloud, advanced modeling, new sensors, cybersecurity, second life, things like that. So we're looking into performance, safety, cost efficiency, sustainability, all the buzzwords that you would expect to see in a European proposal. Essentially, we're trying to address a few challenges. So from a modeling standpoint, of course, there are limitations due to the current hardware. We're looking into enhancing the computational capability, potentially bringing the cloud into this. Different sensors as well. We need to include also bidirectional charging, potentially controlling some of the charging methods as well to account for some of the chemistries that occur during the charging process. We want to take advantage of accessing a lot of data from a fleet of battery packs, and maybe using even battery passport to make some predictions, maybe failure analysis, things like that. And then also the connection between first life, second life probably can be done better. So these are some of the challenges. Of course, from a requirement standpoint, let's say we want to look into durability, accuracy, connectivity, safety, circularity, and affordability as well. We have this is a picture of the consortium. So we have a wide range of skills and capabilities in the project. Yeah, some of the objectives. So of course, we're looking into security. So these are a little bit more top level objectives. Integration. So we try to increase end user acceptance, data standardization. So we collect data. We have actually 3 packs as use cases for testing the BMS. So we're looking into developing a platform which can potentially be used for different battery packs, different chemistries. We have the Helios battery pack, potentially the MARBEL battery pack after the end of the project, and another battery pack from an Italian manufacturer, MAT. So understanding the commonalities between data collection and processing, that's a critical point as well. And of course, IP collaboration with industry stakeholders, those kind of things. So in terms of some of the work packages and some of the things that we're looking into in the work package 1, we did a pretty thorough evaluation of the requirements, stakeholder analysis, requirements on the hardware, software, BMS interfaces, testing requirements as well. In work package 2 on the hardware, we're looking into, we're using a Ficosa platform. We're looking into the firmware updates, potentially new sensors, fiber optic measurements, those kind of things. In work package 3, I'm sorry, work package 4, it's on the software development. So that's a typo there. So we look into database models, physics-based models, in understanding how we integrate the two. Potentially, how do we split the models between edge and cloud computation? Looking at some cybersecurity issues in this context as well. And in work package 5, yeah, we are addressing cybersecurity a little bit more in detail. IoT, cloud computation, second life applications as well. And work package 6, it's about testing on the 3 platforms. So yeah, I think that's what I had on iPad. Thank you.
Thank you, Corneliu, for a to the point and effective presentation. Now, I believe the next speaker, who's Sahib Chakraborty, should be connected online and might be able to speak from his location.
Hello, am I clearly audible?
Great. So I imagine I will change the slides or yeah, you can ask for a slide change and we'll take care of it, Sahib. So Sahib is a researcher, senior researcher leading activities and projects in VUB, the Vrije Universiteit of Brussels, or as I like to call it, Université Libre de Bruxelles. To each their own. And he had his PhD in 2022 with VUB with the highest distinction from the university. And he now oversees as technical lead manager over 10 EU and national projects. So please, the floor is yours.
Okay, thank you. But I have an objection. So we are from the Vrije University at Brussels, which is the Dutch part, and we have also a French part, University Libre de Brussels. We are not same. We are two different university.
I wasn't in that university. I was assuming it was the same thing. Okay, thanks for the teaching moments.
Okay. So I missed the opportunity to being physically present in this event. But it is my pleasure to introduce you the new project that is called InnoBMS, which is a situational aware BMS battery management systems for the next generations of vehicles. The project has been started on 1st of January 2024. I guess the iBatman and InnoBMS are on the same project called. Both of the project get accepted. And the duration of the project is actually 42 months, and we asked for close to around 4 million euro EU funding. And yeah, and you see the grant number. I don't have to describe anything here. Can you please go to the next slide? So this is the coordination team. If you have any details or if you want to get in touch with the InnoBMS projects, these are the 4 persons that are involved in the coordination, administrations, and the communication disseminations part. And I am the technical lead of this project. Yeah, next slide. So these are the project partners. We have a good combination between the research partners and the industry partners. We have also quite a number of RTOs present in the projects, and we have 2 different use case. One is from the Tofaş, Turkey, and another one is from the Iveco, who is being represented by FPT, Arbon. So this project has 2 industrial use case and 2 battery pack to be implemented in the 2 different vehicle type. So that is the backbone of this project. And go to the next slide. What is the objectives of our project? So the first one we are targeting actually, or the ambition is to have best in class BMS hardware and software solutions. And for us, it is a stop shop where we can provide the hardware and software solutions together. And then the second one is actually to maximize the battery performance in extreme conditions. We are talking about the cold temperature start even or at the very high temperature conditions. Then the third objective is to develop a dynamically responsive battery management systems. That means we are targeting to have some updates from the cloud connectivity. So that is what representing the dynamic response. Then also integrate dynamic situational awareness in the BMS. What do we mean by situational awareness? So if there is a fast charging event or if there is a battery preconditioning happening, we are aware about the lithium plating through the EIS measurement, and that is what we are referring to the situational awareness. Then empowering batteries to operate optimally across the diverse situations. That is a bit corresponds to the second objective as well. And then finally, performance without a negative results in the battery lifetime. So that is the top most priority, that when we are developing a next in class or best in class BMS hardware and software, the optimal things we want to achieve is actually the better battery lifetime. So more or less, some of these are actually a bit buzzword, but some of these objectives are really concrete and quantifiable and achievable. And we are working towards achieving these objectives. So next slide. So this is actually what we planned, BMS layout will be look alike. So this is coming out from the activity we are working in since last 1 year. So the heart of this BMS project is the battery pack, where we have wireless CMB, that means wireless cell monitoring and balancing unit, coming from module 1 to N, and all of this CMB are aggregating the data using a wireless network manager, and then the wireless network manager is communicating with a BMS software that is called the SBMS or the main BMS, and that BMS is communicating with the vehicle existing VCU. And also we have an extra edge device where we are testing some of the new functionality which are innovative or coming as a part of the InnoBMS project. So couple of this actually the physics based lithium plating detections, then the thermal management, then the reduce order SOX models, and some preconditioning or a smart derating of the batteries. And we will be testing these advanced functionalities in edge device, and the edge will have two-way communication. In one way, it will establish a communication with the vehicle VCU. In another way, it will be establishing a communication with the cloud detailed models. That means the model we will have in the edge, it is the reflection of the detailed models on the cloud. So they are the actual digital twin running very close to the actual BMS. So some of this feature I already described, which I don't describe. So the BMS is actually, we are targeting it is a scalable in like in energy content wise. That means the same BMS concept will be testing in 400 volt battery pack as well as 800 volt battery pack to see the scalability and to ensure that the method is a scalable energy content wise. So next slide, please. So this is the expected outcomes out of our project. So we are looking for a BMS to be validated at TRL6 in real driving conditions, in real vehicles, and into different use cases. And then also we want to show test-wise that battery lifetime 15 years will be ensured. Then collecting and managing data for accurate second life battery classifications, and also to show the V2X like vehicle to everything. So most probably we will be enabling the vehicle to load and vehicle to charger connectivity. Then use of advanced model and secure real-time battery management to reduce the margin. That means there will be a combination of the edge models as well as the cloud-based models, and this is what referring to the advanced models. Then predictive SOX diagnostics to accurately determine the actual state of health, and this SOX will be implemented in the edge device. And then finally an integrated systems that is highly connected, that is self-testable, and that could take situation wise decision. Next slide, please. I request all of you, if you have any specific comments or if you want to follow these projects, please use this link, or you can communicate the coordinator, Professor Omar Higazi, in case of any questions. The next slide, I guess this is the end from InnoBMS side.
We will now move on to the panel discussion. So Sahib, I invite you to also stay online. I know you're the only one not physically present, so I will try my best to include you in the conversation too.
Okay.
To the other speakers of the session, if you would like to come up with me. And we have Edward also joining us for the end, so thank you. So first of all, before I ask questions, and just so you know, there are no questions online at the moment. So for the people online watching, don't hesitate to write some questions. I will start with the audience. Thanks so much for sticking, for those who stuck all the way here. Do you have any questions for any of our speakers, or a general question even? Well, I was expecting we would all be tired. That's fine. I have a few questions, maybe more general and not very targeted. So if anyone wants to take the floor at any point, please make yourself known. And also, Sahib, don't hesitate to make a sound or something. So if you have a comment. Now we know that BMS, requires a lot of data to be built into to function well. And I was wondering, in the current situation, do you have enough access to data, to public data, also from other stakeholders, and to develop your technologies in that sense?
So maybe I can say from BMS, we have the data from Helios, MARBEL, and MAT is providing some data as well. And at least from Helios standpoint, we did extensive testing for the cells. We've been killing them for about 3 or 4 years, including aging models, those kind of things. So I think we have the data that we need in the project. The way the BMSs might be extended to other platforms, then of course those platforms are going to have to provide data for those specific applications. So.
In our case, we started with no. So the topic of the data is a little bit bottleneck when especially for people working on predictive algorithms, machine learning, etc. And we've been using open data sources available on. Or so that they are open to the public to start training, but it's true that then later it's key point the data. That fortunately now building this kind of clusters also permits to get these synergies and connection between projects, and then transfer data sets, and that permits to continue working on this.
Thank you. And talking about BMS, we always talk about battery generations, Gen 3, Gen 4, even Gen 5 now. Are there generations of BMS as well? How do you see the future of BMS? And I was also wondering, maybe will the role of AI be even greater or expand in the future? How do you see it right now? Don't be shy.
Well, I mean, yeah, for the new chemistries, probably there are going to be a lot of common functionalities. The hope is that potentially what we develop now is more of a process that can be applied to next generation packs. So rather than being, very, let's say, platform specific, right? Potentially what we develop can be replicated in terms of tools, methods, processes to other platforms as well. But we haven't looked into solid state yet, so now we're still at Gen 3-ish.
Yeah, I would also want to add something. So the InnoBMS project is a consecutive project. Actually, we start with project called Next BMS, and the Next BMS is up to TRL level 3 and 4, and where we concentrated more on test and test and test, and we are testing for last 2 years and a half. And all this data now is helping to develop AI model, and will be also transferred from Next BMS to the InnoBMS projects, because the consortium is more or less almost 80% overlap to these two projects. So from data wise, in InnoBMS project, there is no bottleneck, and also the OEMs we have, they are well blended over these two projects. And also we are seeing how to share or how to upgrade the model that has been developed in Next BMS into the InnoBMS, and that also a bit answering your questions. The cell we are testing or the model we are developing in Next BMS, it is on Gen 2, and in InnoBMS the cell in Gen 3. Now we see how to scale it up. Which test we have to perform extra? We are making that list, or the developers are conducting the test in the InnoBMS that needed to move from one gen to another gen. So these questions actually will be a bit answered in the when the InnoBMS come to an end, like how do we scale up from one cell to another, and how do we cover the test needed from one generation to another generations, and what are the effort has been spent to change also the model. So I guess in the AI models, or like the predictive models, the challenge is not that much, because there are a huge experience, or there are a huge what can I say, advancement there. But in that part, the bottleneck is on the physics based model, like when they are developing the physiochemically consistent electrochemical model, their extra effort is needed when the generation or the material has been changed. Like if it is NMC 631 and the next cell is NMC 811, the physical model, for the physical model, it is a different effort than an AI model.
Yes, also in the same direction, I think, for example, when applying advanced algorithms with transfer learning, all we are doing right now, jumping from one technology to other, starting, for example, with physical-chemical models to train your algorithms and then be able to transfer that knowledge to other chemistry. So all that we are learning at that point will be also usable then to jump to other technologies that are coming afterwards. So I think we are reusing many things that we are learning right now also in the future.
All right, of course, in between questions, or even like if you have any question at any moment, please raise your hands. I'll try to keep a look. So none now, all right. I was also wondering, in the context of your work, how do you see the collaboration with non-European actors? So of course, we think about Asia and America. And how is the tech transfer with those partners, or even data exchange? Do you have a lot of collaborations there, or how do you see the future there?
Yeah, good question. Well, I mean, the purpose of the project is to enhance the EU-based knowledge, and yeah, so that probably answers the question. But at least in this format, we don't have a lot of options to go beyond borders. Even with US, right? We could, I mean, the only way we could collaborate, let's say, with some of the US partners is through the advisory board. But certainly not in the project. Potentially after the project, right? So individual partners could develop their own commercial connections. But at least in this European project, I don't see a good framework for us to go beyond, and probably we don't need to. Right. So yeah, after that, it's up to the individual beneficiaries to continue collaborations. But I hope, or maybe, yeah, so, we are disseminating. So probably, the word is heard outside of EU as well.
Yeah, I think in this particular sector, no, and what concerns to the batteries, it's a little bit more delicate topic, no? We were invited to talk about batteries, the two of the partners of MARBEL to Korea, for instance. And I remember from the European Commission telling us, well, let's disseminate, but I consider that in that region there are many competitors. So, and it's like this is a sector that it's very core in Europe, and we are not maybe in the forefront position in certain technologies, no? And it's like we need to take care of this. So in this case, despite in other sectors, the European Commission boosts or pushes for collaboration with other countries, like for instance in Korea, or I know with the production of hydrogen from bio-waste with India, things like this. I think in this one, automotive batteries, we need to be more careful maybe on this, and well, maybe at research level, exchanging data sets, etc. Maybe it's always more open, no, for publications, but yeah, that would be.
Also from the audience, if you have a comment, not a question, feel free. You also have knowledge and experience in there, so don't hesitate to chime in. I have maybe another cheeky question. I'm wondering because I'm wondering about your experience working in EU projects and what the benefits are, but also the disadvantages, and benefits setting aside the EU money, of course, because that's of course interesting. But do you see what value you see, what things could be better in that system, the current system of EU projects, from your experience in there?
Well, we have a very nice case study here with COLLABAT, I think. So there were 4 battery projects. In the former times, normally the projects were competitors. So they were selected in the same calls, but everybody was in a silo and working on more or less the same topics and a different story, and nobody was talking to each other. So COLLABAT was a very, very nice success study with the 3 subclusters. So we created internal discussion groups. So really not to make it public at the first hand. This was the second stage, of course. Dissemination is important, and then we can go out. But first of all, we have to discuss and see what we can do among project partners, among technical experts, to not reinvent the wheel every time, but to really see where we can save efforts or we can overcome challenges. So this is very nice in European projects. Now the idea of clustering is also pushed by the Commission and also by other platforms like BEPA, Battery Europe. So I think that's a very nice story. The challenge is always to find a balance between the internal intellectual property you're developing, sharing the information, what can you reveal, what not, and also to find the support, I think sometimes from European organizations to have a easier platform to how to disseminate the information. I mean, we can do our own webinars, we can do our own workshops like MARBEL here together with Stellantis did today, but we should give a little bit more room to European projects. There are some conferences dedicated to European projects, but maybe on these commercial ones, where it's interesting to have like trade shows on one hand, and then research projects on the other hand. So a little bit more support here maybe could be done.
From my side, I think European projects, apart from bringing you the opportunity to put resources for scaling up a technology or applying a technology that you have in one sector or other. I think gives opportunity to collaborate together, and this goes a bit also on what concerns the clustering, no? To get once you are granted, before maybe it's more competitive, but once you are granted, you are a group of partners from the same sector facing common challenges, no? And this permits to collaborate with not only you alone, but with the providers, end users, the technology provider, universities, academics. So a whole range of the value chain of a particular sector that gives you a vision that perhaps you would not have by innovating by your own. So you have the vision of your end user, you have the vision of the provider that maybe is providing to you some component. And I think this is very rich. So it's very valuable when innovating for having success. Apart from this, you gain a lot of visibility. You have the opportunity to team up with other great researchers, great company, great people, go together to disseminate your results, and even participate to events where there are decisions at policy level about the roadmap in the continent, well, in the European Union, about your sector. So, well, I think there are many advantages. It's true that there are others, and also as coordinator, bringing all the navigation of such a singular and variety of profiles and partners is also challenging. But I think the final balance is very positive for innovation.
Just a question from my side, because I don't understand all the hesitations here to ask questions. They are sitting there, you know. Now you have the chance to tease them and get all your questions done. Don't you think it would be a great chance for the European Union to have, I would say, a two-step sort of funding? The first step that we have done right now, and now we have the bunch of flowers and lots of so good solutions. I mean, I've seen things today I have never seen before. I'm not sure about you, but now we should take all the nice flowers out of there and create the battery pack of the future. So that should be a second type of funding, and maybe a suggestion to the European Commission to establish something like that, like a two-stage, because one solution will always be better than the other, but not in any case. So now we take the Lego bricks and assemble the most perfect battery that is compatible on the market. What do you think? Good solution? Good idea? Suggest that?
I came to my mind in others, because batteries, I think, is very complex, because it came a lot of different components, like high voltage electrical systems, electronics, etc. But there were, I like this idea of having a funding scheme that on the best innovations that are sustained by figures of performance and in all meanings, no? Performance, battery, environmental, and also in business case, the best ones that get some funding scheme for scaling up. For instance, in other like first of a kind, I am thinking of other sectors that they have in the innovation fund. For instance, the technologies that can decrease the maximum the CO2, and they have a business plan clear. They have this final push for scaling up. In batteries, more complex. I don't know, you colleagues, how do you feel could be the funding scheme for pushing the best innovations out of our projects?
Yeah, I mean, the scaling up, it's a good question, right? To me, I think one of the drawbacks is that the consortium, the way it is set up now, is not a legal entity. And so nobody really owns the outcome at the system level, right?
You're right. But the point I had was, it happens much too often that we have the final event today, this door is closing, everyone is going his own way, and everyone is doing a little bit of promotion what he has done, but no one is taking the overall concept and promotes what really has been achieved. I mean, what has been achieved in MARBEL is standing in front of this door, and that should go straight to any trade fair, and this should be funded. You know, that's what I mean. We have wonderful results, but at the end of the project, they appear, and then the project finishes, and now it's time to go to the OEMs and say, look what we got, and there's no money to do that. You know, and that's a bit of a question where I think we could improve this process somehow.
Sure.
So I may have a
Sorry.
comment. So, look, I'm not the commission. I do work with them a bit. I would say that I think it's okay. So the EU doesn't have limitless money. Obviously, it's about where you put it. And once a Horizon project is over, you know, it's of course lower TRL. It's not yet scaling up industrialization. So the next steps are much more expensive actually to you know. And I think the EU doesn't have the money to do that for every Horizon Europe project, unfortunately. And also, it's not always easy for the Commission, I think, to identify which are the really worthwhile projects because they're not always the experts on the technologies. And also, I think every project, not like throwing stones here, but I think every project will always defend its results as best they can. And so it's hard to see through that smoke screen, I think, from their side. Also, of course, there are instruments like the Innovation Fund. You have new projects like Advanding and BMS that are, you know, kind of taking up. But of course, it's not going to take up everything that's been done by the previous projects. Innovation Fund is also limited. Of course, not many people get that funding or organizations open source. Yes. So that would be some kind of answers. I'm not saying like it's an excuse or anything, but I would explain this phenomenon that way as well. And I think the hope of the Commission is that more private funding and investment goes into these technologies after the projects are done. But we see that that's less and less the case.
And to drive innovation to the market, it's key to have the feedback from the market. So I encourage you to answer our QR code and providing your feedback as providers in the sector.
Oh yeah, sorry, I forgot.
No, I just was like on the context, so I just.
Magnus?
So a very short question also, maybe out of the scope, but what is your idea or what is your opinion about what Europe now is facing when it comes to cell production? I'm just living in Scandinavia and see that a lot of the small companies that pops up and are trying to produce battery cells competitive, they are going bankrupt or moving to the US or back to Asia. So how can Europe be competitive again? Not great again, but competitive again when it comes to cell production in respect of innovation, research, and policies. What is your opinion about that?
Well, just I was thinking like for a starting point, and there is a part of MARBEL that we and the speaker could not speak today. But from a starting point, for instance, recovering the material from getting this raw material, this availability of raw material, and also this morning Nero from Stellantis commented, this would be a big starting point because the supply chain for raw materials it's a key point. It's true then how we establish the industry. Maybe some of I would leave the floor if someone have ideas for this. But when you asked the question was going step by step. Step one, like where the materials come from. This is also a key point, and then also how we do the proper investments to be competitive and have the technology, etc.
And I will add as well that in the call in which MARBEL, Helios, Albatros, and Liberty won, the H2020 call, the BAT 10, had a budget to fund 4 projects of 12 million euros each. Now we have 1, maybe 2 project granted of maybe 5, 8 million euros. And there is like between 50 and 100 proposals submitted for every call. So maybe also that have to be tackled. because otherwise there have been proposals not granted with 15 out of 15 of score. So what's happening with that? No? With that innovation lost because there is no budget to grant it.
I think I may have some, I know I'm moderator, I don't want to overstep, but I may have some clues as well, because recently with BEPA, we surveyed our members concerning the developing commission startup strategy. And we wanted to get a feel of what our members think for the battery startups and scale-ups. And 4 main points were risen for the challenges. First one, of course, is investment and money. I mean, I think the Commission anyway is receiving requests from every sector around for more money. So I will skip that point. Second one was Asian competition and creating a more level playing field through, well, I mean, I'm going to say the T word, but tariffs, like this, or tariffs, so, you know, these kinds of measures and kind of, you know, because of course, compared to China, of course, when I say Asia, I think everyone hears China in our sector. You know, socially, environmentally, and in terms of state aid, we're not at all at level playing field, right, in terms of costs and requirements. So there was that. Third one was we have the raw materials, as you mentioned, the supply. We don't mine in Europe, very little. We, of course, the geopolitical situation is making it even harder to secure the raw materials, so there's that. And the last one was, of course, the regulatory hurdles, making it easier for people to actually, you know, industrialize, make things happen, and be entrepreneurs. So those were kind of the 4 main points that were brought up with kind of different solutions, but here, that would be my sense on this. I think with this, we can actually end the session if there are no more questions or comments. I think we're all happy with what we learned here. Thank you very much to the speakers. A round of applause for them again, please. And of course, if I may, as we are nearing the end, I would also like to thank the organizers and the host, Stellantis, and of course, Euricat and MARBEL Project for today. Marina and Network especially, thanks a lot. And I think I'll leave it to the closing session. Thank you all, and have a nice last session.
Thank you. Okay. I'm supposed to close this meeting. I would like instead also to give my opinion on the Christian position on that, because I understand that all of us are seeking for following up with all what we did. I want to maybe give a message in a bottle to the Commission, if somehow, some reason, they can listen to my opinion. That is that one. The Commission is putting money on big product development, in this case, a battery pack. Okay, big money are big, but are also small as far compared with all the investment around the world, China, Japan, companies that can maybe result in peanuts at the end. So we started this project 5 years ago. In the meantime, the world kept going, and the real final product may also be surpassed somehow. So I don't want to put too much stress as a focus to the final product, because the industry knows how to do the business, and it's very difficult, the exercise, the EC, to put together different players for making new product of the future. So meanwhile, we are chatting about packing modules. Somebody else are packing directly themselves, right? So what I want to stress is that we have a good opportunity to select with more precision the key exploitable result. If we open up that package, we see lots of innovation that can be taken by the industry, the player, the tier 1, 2, that can implement an existing product on their product roadmap. This means that you create jobs. Exactly what the mission of the European Commission is. So we shouldn't be sad that if our battery pack won't have as a whole a continuation. What it has to continue is the key exploratory result that must be highlighted, stressed, because these around these we have clients, industry that can adopt it and introduce in a business that maybe is even more pragmatic because they do on daily basis. So this is my opinion to close up your question that is interesting. So now I want just to thank you for your resilience despite the fatigue. So I'm very honored to play host, and all my company did. So I'm very happy, and I want to thank you, you guests on site and the people online. I hope that this type of event, and for that I really thank Marina and the colleagues, the organization, because I hosted, but they did their job and they did it perfectly. So it's a very good opportunity to, the only thing I did is to invite companies of our supply chains to let them see, to open the box and see inside. And so to try to match interest and interest in common that can become novel evolutionary scenarios. So thank you a lot. We now have to, I really please you to QR code this and to give us a feedback, because this is important also for the reporting to the Commission, and also to evaluate the work done by the people who did it. We have a battery pack prototype outside, so in principle we can walk a bit and see what we have done. This is in the context of MARBEL and nothing else. Thank you for joining us.